So in the last class, we discussed about what the AI agents are. Okay. And we also talked about the React pattern, which is reasoning plus action pattern. Okay. And we have seen, how we can make LLM to think also, right? So our aim was, once we give the input, the LLM should be able to do some reasoning. And then based on its reasoning, it should tell us what action is to be taken, and once we execute that action, there will be some output which is called as the observation, which will again be sent to the LLM, and then LLM will do again some reasoning. Okay, it will see whatever output which he has received, it has received, whether is it is that the final intent. If not, then maybe it will, further do some reasoning, further take another action, and the loop will go on until it reaches to a final output. So this is the main, the real reason behind why do we use agents. Okay, we have seen this, right? We have the thought process. The LLM will have thought process. We will give it some problem. It will do some reasoning. It will do some thought process. And then based on the tools which we will provide to the LLM will decide, okay, for this task, what it has to do is it has to make use of one of the given tools. Okay, and then that tool will be executed. Tool or action or function, whatever you call it, that will be invoked, that will be executed. Once we receive the output out of that function, we will have the output, and that output will again be analyzed by LLM to see whether it is able to achieve its target or not, whether it's able to achieve its goal or not. If not, then maybe this will go on, within the loop until it reaches the final answer. So this is called as the React pattern, and this is the most basic principle behind any agentic tool or agent. We have also seen some example, right? How we can create that system prompt, because system prompt is the only thing where we can write the instructions, where we can ask LLM to behave in a particular manner. Okay, otherwise LLMs are the same, right? You just give it some input and it will result in some output. Input some language in and some language out. It will just do the next token guess. It will guess the next token, the most probable next token. That's it. But if we tune our system prompt in such a way, then we can change the behavior of the LLM by giving it some instructions like, you are working in a cycle or maybe in a loop. What your aim is, you have to think, you have to take some action, some observation. At the end, you have to give us some answer, and we will also give some examples to it so that it will come to know the exact expected behavior. Okay. So we gave it that system prompt, and then we asked a question like, what is the total mass of Earth? Based on the system prompt and the question, it analyzed what it has to do. It has the thought like, I need to find the mass of the Earth. And since we also provided couple of functions or tools in the prompt, it analyzed those functions and it has resulted in the output. Okay, I need to, in order to find the mass of the Earth, it has to use one of the tools which are provided, which is like search Wikipedia. Okay, so it will use that tool. It will not use, it will just say that we should use this tool for the answer. Since LLMs cannot themselves call any function, right? Because they are you know they are just large language models. You just give some language or some question, they will reply, but they themselves cannot invoke any external function. This we need to understand. So what it will do is it will just tell, okay, for this question, for this problem, from the given tools, you should be calling this search Wikipedia tool, and it's our responsibility to execute that or call that function. So in the code we have written, okay, if in the output of the LLM, if there is something called as the pause, and the result is having some some text like search underscore Wikipedia, so we use some regex, if you remember, guys, right? So with the help of that regex, we were able to get the name of the tool or the function, and what are the parameters. And then we invoke that function, we got the result. And then finally, that result was again presented to the LLM. Okay, and then it says, okay, this is what the user was expecting. I can stop thinking, and this is the final result. Have If I would have said I need the sum of all the masses, then maybe at first it will, iterate 9 or 10 times to get the mass of all the planets. And finally, it will also call one tool like add the masses, and then the masses will be added, and then it will give the final answer. Okay, I think so far so good. So this was the basic thing which we covered in the last lecture. Now today, what we are going to do is, and we also created that agent, our first agent, with the help of Python. But there were a lot of things which were very manual, right? We were parsing the output with the help of Python or the regex, and then we were calling those functions manually, right? So that agent was something, which cannot be deployed to the production. So, so in order to make some reliable agents, what we can do is we can use some frameworks which are there in the market. And one of those framework is LangGraph, which is again from the LangChain. Okay, so LangChain we have already seen in the detail, right? We have done 2 full sessions on the basics of the LangChain and the advanced LangChain. So in order to use this LangGraph, which is agentic framework, it's not necessary or mandatory that we should be using the LangChain. But since we have already learned it, it is very much compatible with the LangChain as well. Okay, so it will be like cherry on the cake, right? We know the LangChain, and now we are using the same framework from the same company. So LangGraph, which is very much compatible with the LangChain. Okay, so there are other frameworks also. For example, we have, Crew AI, right, which can also be used to build the agents. But the difference between these two are, the LangGraph agentic framework is, it gives us a framework which is very controllable in the sense what your agent is going to do, how it is going to do, right? So that is very much easy to guess, or it's very controllable, right? Whereas if you use the Crew AI, so what you need to do is you need to give the goals and tasks, and then it will itself figure out what to do. Okay, so in order to create applications which are more trustable, more reliable, the applications which can be brought into the production, LangGraph is the way to go. Okay, so that's why we will use the LangGraph to build some agents. Okay. So in order to learn the LangGraph also, there are some, what we will do is we will create some workflows, and there are certain things called, uh, first we will set up the LangGraph library. We need to install the LangGraph. We will see what are states, what are nodes, which are required to build that workflow, build that agent. And then we will create our first graph. We will also see what is tool calling. There is something called tool calling or function calling. You guys must have, heard about it. This is very important concept. Okay, the concept is exactly same, right? In the last session, we saw that if we need to use the tool, then LLM will be able to tell us this tool is the appropriate. Okay, so that is called tool calling. We will see it into in a much detail. And then there is something called as the tool node, which will help us to do this tool calling in the LangGraph or in our workflow. And then finally, we will build a React agent in the LangGraph. Okay, I hope that's clear. So today's session will be more on the coding part. Okay, there is nothing too much about the concepts. We will learn the concepts while coding. Okay, so this is one sample uh, agent. So what LangGraph does is LangGraph give us the provision to build or to see the agent in a visual format. So a graph is always have a start node and the end node. Okay, so the LangGraph framework provides us the starting point and the end point, and within the start and end point, our entire logic will be there. And what it will have basically nodes. So this assistant is a node, enter write sequence is a node. So there are a couple of nodes between the start and the end, and those nodes will be connected with the help of edges. So this is one edge, this is second edge. All these are edges which connect different nodes. And what happens is, you can think about the workflow. We have to build this workflow as per our requirement. Okay, so you can think it of, we will, some data will be entering into this particular workflow or graph, and the state of that workflow or that data will keep on changing when it moves from one node to the other. So you can think it of, maybe a message, a list of messages. Okay, so that list of message will enter into this graph. Maybe let's say this is a LLM node, so it will call some large language model, it will receive some output. So what it will do is, it will append one more message into that message state. Okay, then maybe it will go to this assistant tools, it will execute some tool, some output will be received, and that the output will again be appended into my messages state. Okay, so whatever things which are happening in all these nodes, they get appended to my certain state, and in the end of this operation, what will happen, I will receive one updated state. Okay, so this will become more clear once we execute all these things. Okay, so the basically a data flows in this particular graph, and its state keeps on changing based on what operations we are doing on the different nodes. Okay, so initially we'll start with a very simple graph where we will have the start node and the end node, and in between we will create two different nodes, and we will see how we can create these node 1, node 2, how we can connect them, and then we will add little bit of complexity by putting some condition at this node 1, which will decide whether it should go to node 2 or node 3 based on that condition. Okay, once it enters into either of node 2 or 3, it will eventually end. Okay, or maybe we will directly build this one. Okay, this one, and then if you remove this condition, it will become the first one. Okay, so these are simpler graphs which we are going to build today. And then we will add the concept of tool calling. Okay, so we'll start with a simpler graph with the LLM. We will see what is tool calling and how we can enable our large language model to do the tool calling. And then we will again add a little bit of complexity, where we will be having the LLM node, and that node will decide whether LLM will decide whether it has to invoke any tool or not. If not, it will directly end. If it feels okay, it has couple of tools bind with it. For example, as we see in the example, right, if we need to calculate the mass of any planet, the LLM will analyze, okay, I need to calculate the mass of the Earth, and it has a tool called, Wikipedia search. Then it will call that tool. That tool, after the tool calling, it will end. And then we will again add some complexity, saying that once that mass is being calculated, it will return the result to the LLM node, and then it will see, okay, this is what it was intended by the user to calculate the mass of the Earth. Now it has calculated, so it will exit. Okay, if we say calculate the sum of all the masses, then maybe this will loop will go for 10 times or 9 times. How many planets we have? I think we have 8 planets, right? 8 planets, so it will do the looping 8 times, and then finally it will exit. Okay, so this is exactly the React agent which we built in the last class with the help of Python. And now we will learn how we can build this uh, agent with the help of LangGraph. Is it clear, guys?
Yeah.
Any question? Okay, so far so good.
LangGraph,
Hmm.
LangGraph is just replacement of a React, we can say.
Yeah, so React is basically a concept, okay, which says that how we can make our LLM to reason, okay, how we can force our LLM to take decisions on our behalf, whether it has to call tool 1 or tool 2 or tool 3. Okay, so that React pattern or that React concept first we implemented with the help of plain Python, where we had to do a lot of things manually. Now we are going to use this LangGraph, which will help, which will give us couple of more things, which will make our life easy in implementing that React pattern. Okay,
Oh.
ultimately we will create one React pattern based agent with the help of LangGraph, which will be more which the behavior of that agent will be more predictable and more controlled way, which we can deploy in our production application. Earlier was, that was not predictable, or that could not be trusted, because we were doing a lot of manual interventions, and then we were parsing the output, and then we were executing the functions, right? So in order to avoid all those things and to develop some production ready application, we will be using LangGraph. Okay.
So, Surinder, which type of libraries are you can say classes and all inbuilt and which will use from the LangGraph to ease for us?
Yeah, so we will see that, we will just start the coding, and then we will see all those things. Okay.
And what is the major difference between LangChain and LangGraph? Only just React pattern or something else also?
No. So LangChain is a different framework, right? Which helped us to create the different objects, like creating the
Mm-hmm.
chain of different objects, or the runnable objects. How to invoke your LLM, right? Now
Mm-hmm.
they have also created one another framework which will help us to build agents.
Okay, it is
Okay,
agent. Is the agentic one only for
exactly.
agentic. Okay.
Yeah. So with the help of LangChain, you cannot create agents. With the help of
Mm.
LangGraph is a library basically. It's just like
Okay.
pip install LangGraph now.
Okay.
Okay. We will start the coding part. So I hope you can view my screen.
Yes.
Okay. So first I will remove. In fact, I don't need this one. Okay, let it be. So let's install the LangGraph. Okay. This is to load a .env file. So, but in this collab, we'll use this one, right? So we don't need. So this is that library which is from the LangChain on the LangGraph. So this has got installed. What next? This is what I was saying. We need to define some schema or some state. Okay, so this is very important. So we have defined that, okay, there is a class state and it's a typed dict. Typed dict means dict is dictionary. Typed dictionary means the dictionary having the key value pairs
EML.
which are very uh, which are very strict to the data type. Okay, usually in the dictionary we can put integers, strings, and everything, right? Now we are creating a dictionary which is strict to the type of variable which we are saving. So that type is string in my case. Okay, so this is my state, my key, and the type of my key is string. Okay, so I have defined this schema. So this state will be passed to my entire graph. Okay, and then I will be creating the nodes first. Okay, what I will do is create nodes, and nodes are what? Nodes are nothing but these are our functions. Okay, and here we have seen that these all nodes are nothing but some operation or some functions. So what I have done is I will be creating three different nodes. This is my node one. This is the definition. Okay, the node one will take my state. Okay, so this state we have defined. This will take my state And first we are printing the current state. Okay, state, my state is what? My state is the key. Okay, so I'm just getting the value of this key from this object state and just printing it. Okay, node 1, whatever current value it has for this key, my underscore state, it will print. And then what I am doing is, as a part of operation in this node 1, I'm going to update this state. So I'm creating a new state, which is like, which is again a dictionary, and the key of the dictionary is my state. Okay, and the value is what? For the value, what I am doing is I am fetching the earlier value and appending I want to travel. Is it clear, guys? What I am doing is, whatever value which is there in this key for the state object which is passed while invoking this node, I am fetching its value, and then I am appending this piece of text and setting that new value, the appended value, into my key again. So I am overriding or overwriting my state. Okay? And I am returning that new state. सबको समझ में आया कि नहीं आया?
Yes, Surendra, got it.
ठीक है? In the node 2 also I am doing same. I'm in the node 2, whatever state of this object which is being passed while invoking the node 2 was there, I am fetching that state and adding, appending this Germany, and then returning. Same thing, Italy or Germany. Okay, easy. So we have defined the nodes. What else we need, guys? What else we need to build our graph? Okay, oh yeah, that's fine. So I'm directly jumping to this one. Okay, instead of this one, this is a very simpler one, so I am using this conditional node. Okay, okay, so what I'm doing is, again I have defined another node or the method which is decide a destination. Okay, it is also taking the state. Okay, and the probable outputs are node 2 and node 3. Okay, so this is just the syntax. Okay, don't get afraid. What is this? This is just declaring that the input of this function is of type state, and this is the name of the object, and the output of this function is literal, means one of these two, node 2 or node 3. Okay, here we have not defined because it's not required. I mean, the function will work, but somehow this LangGraph actually, in order to decide where the control should go, it
And what does this arrow sign do here?
arrow sign is the return type. Basically, for this
Okay.
function, what is the return type? The return type is literal. That means either node 2 or node 3. This is what exactly we are doing. We are returning random dot choice. This is some Python function, so which it will randomly pass node 2 or node 3 as an output. Okay, or just wait for 2 minutes, you will see it in action, then you will be able to understand. So we have defined our nodes and our conditional node as well, which will decide where it should go. Okay, so now in order to see the graph, okay, which I shown you here, in order to see the LangGraphs in the graphical mode, what we need to do is we need some Python function, which is like import image and display. This is IPython library. And from the LangGraph, we are also importing state graph, which will help me to build this graph, and start and end. So these are the start and end nodes. Okay, so these are three important classes which we need to import. And then I define builder. Okay, this is my graph builder. Basically, builder is equal to state graph. I am using this class and I am passing the state. Okay, so right now what I'm doing is I'm actually building this workflow. Okay, in order to build this workflow, first I declared these functions, then I also declared these nodes. Now I am connecting them. In order to connect, first I need to create a builder. which is nothing but the instance of this state graph, which is a method from LangGraph. And I'm declaring that it should take the state, okay, the state which we defined earlier. This one, okay, the schema basically. So this is my state, and then builder dot add node. This is node one, builder dot add node two. So I have added all these three nodes which I defined here. Okay, it may look a bit complicated at the first place, but eventually you will get habitual. Okay, so we are added three nodes. These are some names to these three nodes. These are the name of the exact functions. We have given them names as node 1, node 2, and node 3. So we added these nodes into my builder. I also need to add the edges. Okay, how these nodes are connected to each other. For that, I'm saying the first edge is from the starting till node 1. Okay, if you see from start to node 1. So what I want to do, I want to connect these two nodes, start node and node 1, with this edge. So in order to define this edge, I need to tell what is its starting point and what is its end point. So for the node 1, for this edge 1, builder dot add edge start to node 1. Okay. And from node 1, I have two ways to go. Either I can go to node 2 or I can go to node 3. So that condition I need to define. For that, there is a function called add conditional edges and condition from node 1 where to decide destination. Decide destination is again the method which we defined here, right? The logic of, going to node 2 or node 3. In real life example, this will be something else, but for the convenience, I'm using randomly. So randomly it will choose either node 2 or node 3. In real life, there will be some complex function which will decide that either it should go to node 2 or node 3. Okay, maybe we will call some large language model. And on the basis of the output of the large language model, I will decide whether I should go to node 2 or node 3. If the output is to call the tool, I will go to node 2 maybe. If it does not require any tool, it will go to node 3. Okay? So I have defined that conditional edge. Starting point is node 1. It will go to decide node function. And from there are two possible things, right? Either it will go to node 2 or node 3. In both conditions, I need to end. That's why I have defined two more edges, node 2 till end, node 3 to 2. Okay, I hope this is making sense. ठीक है, node 2 से end तक, node 3 से भी end तक. So I have defined all these edges. Start से node 1 तक, node 2 से end तक, node 3 से end तक, node 1 से conditional function तक. That function will decide the way. So all those conditional edges are actually shown with the dotted lines. Okay, and the others are shown by bold line, solid line. Okay, so our graph is ready. Builder.compile. This is my graph. And if you want to see the graph, this function we will use display image mermaid PNG. So there is a method called draw mermaid PNG. Let me execute this. So this is our graph. Okay, start node 1, condition, either it will go to node 2 or it will go to node 3, and then it will end. Okay, simple. Any questions, guys? So, I mean, this is purely syntax thing, which you need to take care. All right, moving next, what I need to do is I just need to, now my graph is ready. I need to invoke this. And as I said, since we have already learned LangChain, okay, now it's easy for us to understand how to invoke, because this graph is also a runnable. This is also a runnable object. So I can use, I can use all those functions which are applicable for any runnable objects in the LangChain, that is invoke. Right? Earlier we were doing chain.invoke, right?
Correct.
Correct. So similarly, the graph is also a runnable object. So I can do graph.invoke, And what this graph is looking for, this is looking for that state, right? And the state, the definition of state is something what we have defined. It's a typed dict. Okay,
So
typed
then
dict.
here also we can
Hmm.
use the three like invoke and batch and third one, huh?
Yes, yes,
Same methods.
correct. So if you see what is typed dict, a dictionary with sticked type. Just a second. Typed dict by again types लिख दिया मैंने इसको. Typed dict lets you define a structure of dictionary which where specific keys have specific values, like defining dictionary type. Okay, so our type is string, so we can define some uh, you know uh, dictionaries, like they should have title of the string type, they should have year which should be in the integer, they should have rating which should be in the float. Okay, so we are not only declaring the structure of the dictionary, but in the type dict we also define the type of those keys basically. Okay, so we are putting that strictness, basically strict, typed. All right, so now we have to invoke this, right? So what I have defined is my state. This is my state, my key, and value is hello there. So what will happen? It will go to my node 1 first. Okay, this will go to my node 1. What my node 1 will is going to do, it will say that node 1, and it will print the value of my state. So what should get printed here, guys?
As of now, there is no value in the state.
No, there is one value, right? Which this is
Hello there.
hello there.
Yeah, hello there. Hmm.
Okay. So hello there will be printed, and then it will, from there it will go to either node 2 or node 3. If it goes to node 2, it will print hello,
German.
hello there, I want to travel to. So after leaving from the node 1, its value will update it to hello there, I want to travel to. If it goes to nodes 2, Germany, otherwise Italy. Okay. Let's run this one. Hello there, I want to travel to my state. Hello there, I want to travel to Germany. So if I keep on running this one, what will happen is Italy, Italy, Germany. So randomly it will choose either a state node 2 or node 3.
So, how it's selected randomly? Is there any
So,
random
so
method there?
yeah. So random function is there, na?
Okay.
So it will return any value of randomly out of these two. Okay. In real life, we will use some LLM and we will see whether the output is some tool. That tool can again be, if you're using 10 or 15 tools, the name of the tool, search Wikipedia or calculate or find the temperature or blah blah. Okay. Fair enough, guys. This is our first agent with the help of LangGraph.
From the starting node, we are guiding him to move to node 1. And then after,
Correct.
that method would decide where we can go, node 2 or node 3.
Exactly.
Mhm.
All right. So let's increase the complexity. What is our next target? Next target is to on the tool calling. Okay. So first we need to understand what is tool calling basically. Tool calling is as we have seen in the last lecture, LLMs cannot itself can call any tool, right? They cannot invoke any tool. They don't have any functionality like they can invoke some tool, or they can go to some database, or they will go and search the web or things like that. But what they can do is at the max that they can, if we bind some tools with those LLM, they can at least tell us which tool is appropriate to be called. Okay, if we have 10 different tools, and if we bind or append the names of those tools with my large language model object, then LLM can basically tell, okay, based on your question, I think I don't have any answer to your question, but since you are saying that I have access to these 10 tools, maybe you should use the tool number 7. Okay, so it is doing nothing. It's not calling the tool, but it is just telling us which tool is appropriate to be invoked for the problem statement which it has been given.
So
Okay,
in that case, it will analyze all the connected tools, LLM.
correct, correct, correct. So let's see this in action. Okay,
Tools in the sense, Surendra
functions
ji,
only, functions
application.
only,
Acha.
functions only. Python
Hmm.
functions. Those functions can do anything. They can update some database. They can go to Snowflake. They can, call some APIs, some weather.com APIs, or they can call some, some other LLM, or they can do anything. A Python function can do anything based on its definition.
Suren, even tool can be like Gmail or Salesforce or some
Yes, yes,
some
yes.
some integrated things, huh?
Anything, anything. Right? Basically, what we are expecting from LLM is just to tell us what tool should be invoked. Okay, that reasoning. Otherwise, what we will do, we will be deciding, okay, on this situation. I mean, let's say if we are given any task, right? We are given a task to bake a cake. So we decide all the things, right? Okay, in order to bake the cake, I need eggs, I need, bread, egg, whatever, right?
Mm.
Chocolate or anything. So I decide all those things and then one by one I execute. Okay. I don't have eggs, so I need to place an order. I don't have bread, so I need to, find it in the fridge. If it is not there, then I need to go outside. So all those logical things which a human was doing, now we want LLM to decide with its own logic. Okay, whatever capability it has. Ultimately, what we are trying to do, we are trying to build some machines, LLMs. We want them to mimic humans, right? The way human thinks, the way if we are given any task, we break it down into simpler tasks, right? Task 1, task 2, task 3, and then we try to execute one by one. So same thing we want from the LLMs. We should be able to, end of the day, we should be able to build some applications which LLM can decide what tools to be called. Once the output is there, it should be able to decide what should be its next course of action, so that a complex task can also be executed automatically without having human in the loop. ठीक है, अभी अपन इसको देखते हैं how to, what is tool calling. Okay, so let me use, I'm installing LangChain and OpenAI. Okay, I can use Grok also, and I have to be very careful when I'm choosing any LLM. It should support the tool call. Okay, so let's say if I go to Grok models. So this is 3.3 versatile. If I go into the details, I need to be sure that this tool use yes. Okay. So I have to use only those LLMs which support the tool calling or tool usage. For example, we can use this model, but not all. So you have to go into the model card and, for example, let me check in the Gemma. It has routed me to the Hugging Face. Okay. So you have to find it out. Whisper is a different type. Okay. So it's a must that it should be able to tool use. Okay. So now most of the modern LLMs are supporting tool use because this is very much essential. So you have to make sure your LLM support the tool call. Okay. I have installed my libraries. What next? My OpenAI keys. But what I will do, I will enable OpenAI. I will use this piece of code instead of this one. Copy. I have imported my OpenAI key. So now this is important. So what I'm saying is LangChain, OpenAI, Chat OpenAI, this is cool. Now I'm defining a function or a tool called multiply. It has two parameters. Both are of integer types and the output is also integer type. Okay, so this is syntax, nothing. And one of the most important thing is whenever you are defining any tool which you want to bind it with your LLM, you should have this multi-line comment which should be detailed so much that LLM should be able to understand what your tool is going to do. Okay, so we are defining, okay, multiply two numbers, arguments are A, the first number, B, the second number. If you are defining any tool, your this description should be clear enough, which can help or enable LLM to understand what this function is going to do. Otherwise, it will not be able to decide, right, which tool it has to use. So this detail is very much important. Okay, and the return is A into B. Super. So this is my tool. Now I have defined large language model is equal to chat OpenAI GPT-4o mini, and this we have already seen, right? Now what we are doing is we are defining a tools list, and within that list I am putting this multiply, my function. Okay, so if I define 10 different functions or tools, I can put them like this, right? Whatever their names are, I will say this is the list of my tools which are with me. And what I will do is LLM dot bind tools. So there is a function called bind tools where I can append this list of tools. Now the object I'm having is LLM with the tools. So this is LLM without tools. Once I append these tools, it will, I have named it like LLM with tools. Okay, so now this LLM is having access to the tool methods which we have defined. Okay, fair enough, guys. This is the way to define the tools and bind the tools. Now, if I see this object, which is having LLM object, which is having access to the tools, and if I change it to dictionary, and let's see what all it has. So this object is having what? This is having some configurations, the arguments are having tools. Okay, functions. The description of this function is our tool is multiply two numbers. Name is multiply. What are the parameters? First parameter is A. Second is B. What is the description? This is the first number. So whatever definition which I created here, now that will go to my large language model in order to decide whether it has to call this tool or not. Whenever necessary, it will call this tool. Okay. If not required, it will not call it. That's why this definition is very much important. How you write?
Suren, this definition multi-line comment, what you can say it like a prompt or what these things? This multi-line definition because LLM is choose there and it displays very well in the
Mhm.
result. So what we can see this multi-line comments because it's required.
No, I
Uh,
didn't get it.
it likes the system prompts or here something only comments only. This multi-line comments.
So yeah, whatever function we are defining, its
Mhm.
definition along with the comments is going to the LLM in the form of these arguments. Okay, so they should be clear enough so that LLM can understand what this function is going to do. So when we are doing, so this is not a prompt or anything, right? So this is a function and there is a different way to associate it with our LLM.
No,
Okay, so
I'm
there,
getting this. I'm getting this. I'm
mm,
just only
mm,
asking about this. No, this beauty of this comment there
uh-huh.
because LLM is getting that things and it explained very well there.
Correct, correct.
Okay.
I hope you are clear, right?
Got it.
Whatever your this function is going to do, that should be described here very clearly. Okay, multiply two number. If you write, if you don't write this line, LLM may not be able to understand, right, what your function is going to do. So it may hallucinate, right? It may call some other function, right? So these comments are very much important so that LLM will understand what our function is going to be doing. Okay, so all these things are going with are associated with our large language model as a parameters. Okay, but at the same time, if I see, if I want to see what is there in my earlier object, okay, my earlier object was just LLM, right, without any tools. So if you see there, there is no definition, right? If you go in the arguments, there is no tools because we haven't associated. Okay, so if you call this particular LLM and if you want to do some operation which LLM cannot do, and if it is trying to look for any tools, since there are no associated tools, it cannot call any tool. It will anyway not call any tool, but it will say which tool to use. Okay, which we will just see. Okay, so you see the difference, right? If I don't associate, it will not have that definition of the function or the tool. Okay, so it cannot use in that case. All right, so
So here we need to define that data type as well, like integer or float.
yes.
Okay.
Okay, so let me call LLM with tools. Okay, with this question. Okay, my question is, what is a neural network? So if I see that response, so do you think this question actually needs any tool?
No, don't think.
No, right? So it will not use any tool, although it has access to the tools, but based on the question, it will answer itself, right? So you can see the answer is there in the content. Okay, so the content property will have the answer. A neural network is a computational model inspired by way, blah, blah, blah. Okay, and let's say if I ask a question which will use a tool, then just see how its response changes. Okay, now the question is something different. Multiply 3 by 4. So if I ask that question, and if I print the response, so what its content is empty this time, because it's not able to, it's not replying it in the way it used to reply. Rather, it's telling me in the additional arguments in the tools call property that you should be calling a tool or a function. Okay, and the name of the function is multiply, and with you should call it with these arguments, from where it has got the value 3 and 5 from our question. Okay, so this is the main funda of function calling or tool calling, which sometimes, it's very difficult to understand this concept from YouTube. Okay, I also took, some time to understand this, but here you can see what it is all doing is it is not able to call that function, but it is just telling me that you should be calling one of the tools which is associated with the LLM with the tools, and you should be passing the arguments as a equal to 3 and b equal to 4. The name of the function is multiply. Now the value which we were parsing in our last session, right, using some regex, now it is coming out in a very much structured format, much more reliable format. Okay, now what all we need to do is we should have some LangGraph functions or nodes which can read this tools call, and we should read the name of the function and argument, and they should be able to call that function. Okay, so you can see the difference between the response. Here the content is having some content, but there is no as such tool call, right? In the second, where a tool is to be invoked, the only thing LLM is doing is it is just telling us the name of that tool which we should call or which is useful as per our question, and what should be its arguments. And this was possible only because we have associated a tool and we have defined its definition in that comment. Okay, clear? Now let's try to implement this in our agent, this concept. Any questions, guys? कुछ confusion हो रहा हो? All right. So now there are some more things which LangGraph has introduced. For example, the earlier we were using some class, right, with the type dict, and we were defining our own key. So now what they have done is they have further automated, and they have created this schema which is already there in the LangGraph, and this says that the name of the keys is messages. Okay, and it is, what is the messages? Messages is the list of messages. Okay, for example, AI message, and then human message. Human is asking any question, then AI will give some response, and then maybe there is a lot of iterations. So all that history is to be passed to the LLM, right? Each time. What was our earlier question? We wanted to calculate the mass of the Earth or all the planets. Initially, we calculated the Earth. Now we have calculated the mass of Venus. So it should have history of all those conversations, right? So what LangGraph has done is they have created this class, okay, which is having this messages as a key, and it has, and what is the type of these messages? Earlier we were having the my underscore state as a string, but this messages is a list of messages basically. Okay, and what they have also done is, if you go and see the definition of all these classes, they are automatically appending the messages into this class also. As you call, as you execute any node, whatever the output will be there or the message will be there, it will be automatically appended to the messages key. Okay, so let me do some practical, then it will be more easy to understand. So now what we are doing, again we are importing the same Python class which will help us to display the mermaid PNG, and then LangGraph, from the LangGraph.graph state graph, with the help of which we will create our builder, start node, end node. This is that message state, okay, which I am talking about. Class is also coming from LangGraph framework. So this is what they have done, right? They have automated a couple of things so that we need not to take care of all those things explicitly. Okay, so this is the message state, which will have the list of all the messages, and they automatically get appended into the list. And this is our core messages, AI message and human message. This we have seen. Now, if my initial state is like my AI message is hello, I am Sherlock Holmes. This is the human message. Hi, I am John Watson. How do you solve a mystery? So these are the two messages in my initial state. Okay. So once I will build my uh, graph, I will be invoking with this initial state. And then what I'm doing is I'm defining a tool calling node. What it will take as an input, the message state. Just like earlier we were using my underscore state key and the state class. Now my input type is message state. Okay, this class, which is already there. This is my input state. I'm printing some hashes, 80 times hashes, and print entering LLM node. This is just for debugging purpose. And then I'm iterating all the messages which are there in my state. Okay, because messages is my key. Okay, so I will see if there are 10 messages, then this loop will run 10 times. There is a method called prettyprint, which will display the messages. And then I am calling my tool, LLM with the tools, my large language model. And then I'm sending this state, okay? Sending this state object again with all the messages. Whatever response I will receive from LLM, that may have, it may be telling the answer directly, or it may be saying you should use the tool, or some tool call basically. Then some couple of debugging response will be printed, and we are returning the response. Okay, in the same key we are putting the response object, and it will automatically get appended to the earlier messages. And then we are defining this builder in the same way, add node, tool calling node. Okay, and this is the tool calling node, and edge start. This is what we are going to do. Okay, tool calling node. So they have this special function called tool calling node, and then edges start to tool calling node. Okay, from start to tool calling node, and from tool calling node to the end. Just one step, just one node. And what this node is going to do, it is doing nothing, but it is just invoking our large language model, which has access to some tools. Okay, we are not taking any decision based on the output. This we will do later. Okay, these two we will do later. Right now we are just trying to see if we how we can put our tool calling capable LLM inside our graph. Okay, so simple enough. Let me, and then this is, I am just displaying my graph, start node, tool calling node, and this end node. Okay, any question, guys? Any confusion? Any questions? It may look complicated a bit. Once you get familiarize yourself with all these concepts, I think it will be easier later. Okay, for the first time, I think it may be a bit heavy to understand. I mean, that's the beauty of LangGraph. If you understand it once, which is a bit difficult, if you understand it well once, then it's very easy to build the agents. Okay, we have done a simple thing. Created this graph, start node, end node, this LLM. We are just invoking the large language model, which has access to the tools, and it will give us the output. Okay, that output will again depend whether it's calling the tool or not. That is what we are going to see, whether it's calling the tool or not inside our agent. Okay, in order to invoke, I have that very simple statement. This is runnable. So graph.invoke, what I'm passing my initial state. My initial state has two messages. Okay, and then let's see the output. Entering the LLM node, input message, AI message, hello, I am Sherlock Holmes. This is what we already provided, right? What is the AI response is? Ah, Dr. Watson, solving a mystery involves a methodological blah, blah, blah. So what it has done is it has not used any tool call because it was not required. Correct, guys? It was not required. Now, if we invoke this same agent for a question which needs to call the tool, then let's see how the output will look like. So this time my message is how much is 3 times 4? What is the response? Tool calls. You should call a tool. The name of the tool is multiply. What are the arguments? 3 and 4. So this is my output. Okay, so I have compelled my LLM to tell me what tool I should call. Okay, this may look simpler, but this is a very important concept to build some complicated applications. Good enough, guys? Any question, any problem? So now we will move how we can invoke this LLM, and if the response is like this one, where we need to call a tool, we will again use a tools node, which is again given by LangGraph. Otherwise, we have to do lot of, lot of coding to execute this and to keep it more controlled. But thankfully, LangGraph gives us some methods which can calls the tools automatically. Okay, so we'll use that capability. So if the LLM says I need to call the tool, it will be called automatically. That's why this is dotted. So we'll put some conditional node, which will see whether it has to call the tool or not. If not, it will end. If the question is simpler like this one, solve this mystery, it will directly end. If it is like 3 into 4, it will go to the tools and then end. And if you want to go back to the LLM node, what we can do is we can put some again a logic from tools. We will go back to the LLM node. Okay, so we need to define the edges in such a way. In this case, we have to define the edges from tools to end. And in this case, we need to define the edge from tools. We should go back to the LLM node. Okay, so let's try this one directly. Okay. Okay. Is it looking interesting or boring?
Interesting.
Oh, chalo. Okay. So let me directly copy paste the code. Same stuff, multiply. This is the same only, right? Okay, this is let's use this one. Okay, so this time we are defining two tools. One is Celsius to Fahrenheit. Again, second is get temperature. Okay, so there are two different tools, and then these tools are put in the tools list, and this list is appended to llm.bind to my llm. Okay, llm.bind tools, and this bind tool is, by the way, what this is from the LangChain. Okay, so this is the LangChain object which bind your tools list to the large language model, and this is my final object. And then again defining the LLM node, doing nothing. Whatever the message state is there, I'm passing that state into while invoking my LLM with the tools. And then this time what I'm doing is I have added this LLM node, and then I have added this tools node, okay, which will see if the output from this one is, it will not see it, it will just append the tools node. Okay, and then this conditional nodes will decide from start it will go to LLM node, from and then condition from LLM node it will see whether it has to invoke the tool or it should end. Okay, so this is done by tools condition. Okay, and then finally the tools will come back, the output from the tools node will go back to the LLM node, and we are compiling it. If you see the graph, from the tools node we are going back to the LLM node, and if required it will again call the tool. Since we have two different tools, right? So what it will do, if it sees, if it observes that I need to call my get temperature, it will call this tool, it will give the temperature. Now it will see, okay, I need to calculate the temperature in Fahrenheit. Okay, I have got the temperature of France. Now I have to convert the Celsius into Fahrenheit, so it will again call the other tool, convert to Fahrenheit, and then it will come back with the answer. This is the agentic one, right? The React pattern which we have seen in the last time. So it will do the reasoning. It will do reasoning. Once it receives the final answer, it will end. Okay, so let's test it. My question is, what is the temperature of Paris in Fahrenheit? Okay, but if I look at my method, this city temperature, get temperature, then it's giving me what? Get the temperature of a city in Celsius. Since I'm asking temperature of which country? Paris. Okay, Paris in Fahrenheit. First, it has to calculate the temperature of Paris, but it will be in Celsius. Okay, so it will calculate for the Paris what it is, 22 degrees Celsius will be returned to my LLM. Now LLM will see, okay, I had to calculate in Fahrenheit, but now I have in Celsius. I should be calling Celsius to Fahrenheit tool. So it will again call a tool which is Celsius to Fahrenheit. It will tell us what should be the name of the function, what are the arguments, and then that tools node will automatically call that tool and give the result back to my LLM. Okay, you can see how the things have got automated. So let's call this one. Okay, entering into the LLM node, what is the temperature of Paris in Fahrenheit? It says you should first get the temperature of, you call this function with the parameter Paris. Okay, and then it will say what is the temperature, it is the same message. Then once it get the temperature as 22, it will again call the other function which is called to Fahrenheit. It will give 22 and then it will convert it into Fahrenheit, and this is my final. And the temperature in Paris is 71. So you can see how easily I was able to accomplish this task of converting or getting the temperature of Paris in Fahrenheit. So you can just think of these agents, are that power or that those things which can accomplish a complex task by breaking it down into smaller pieces and then doing it one by one. Okay, are you, I mean, are you guys able to visualize that how we can build some complex workflows which can accomplish something complicated, right? By just building this graph and defining these conditions, defining our tools, and then finally I should be able to achieve my goal. Okay, so yeah, this is what our aim was. Okay, any questions, guys? So I mean, today's session was more on the practical. So we coded all these things. We started from a simpler LangGraph, how we can build a simple LangGraph, and then we put the condition, and then we talked about what is function calling. And the function calling, LLM is not going to call any function, but it will just tell us the name of the function and its arguments. And then thankfully, LLM gave us some nodes, like some functions and nodes like out of the box tools node, which can execute those functions, will return the value, and then it can iterate as long as it is required, and then finally exit. Okay.
Surinder,
Hmm.
any industry or any production use case for this? So it will
Yeah, I
better
mean,
to
yeah,
already.
yeah. I mean, I built one LangGraph agent where the requirement was, in my company, there were a lot of teams who needed to create queries for their databases and for their businesses again and again. The same query they were actually, trying to create from, I mean, they were going to the Google and then they were trying to create those queries themselves. That was taking a lot of time. So what we did was, we asked them to list all the queries which they have written in the past. So
Mhm.
they made a list in the CSV file with couple of columns like the query, whether that query was in Python or SQL. They written the query and they have also written the motive of that query. Okay. And then we took those files and we vectorized those files and we put them into some vector database, and we created one agent which where there were a couple of nodes. For example, the first node will now let's say the user wants to create similar query for a given table. So he will simply write in the natural language, I want to know the top 5 customers from my company, right? Uh, from where we get most of the revenue. Okay, so this is just a sample. So what it will do is first it will go to the first node where we have our RAG implemented. It will just check whether we have done similar query in the past or not. So it will go to that CSV file, the chunks of the CSV file, it will match the query. If it is able to find the similar query, it will fetch that content, and then it will go to the LLM with the question that this is the question and this is the similar queries. So what it will do is it will able to come to know the different tables and schemas which are there in the CSV. So it will build some query. Now I have created another node where I was testing whether the syntax of this query is right or not. Because before giving it to the user that this is your query, so I should test the syntax. So I have written some Python code which will check whether that Python or SQL query is syntactically correct or not. And then there was one another node which was telling the more about that query, how to use that query, how to run it query, what should be the expected. So like that, I mean, you can build your own workflow. So we
So
created
there, so
those.
so there you were using the three tools. One is the rack, where you will get the
uh,
knowledge base from your
Correct,
old cases, and the
correct.
second node you just do some Python function and check the syntax. And third one, you precise the result and share with the user like
Correct,
this one.
correct, exactly. So there were three different tasks, and they were put in a one LangGraph agent. So they got executed one by one, and the user will finally get the answer for this question. This is the query. This is how you have to use it. I mean, you can customize it, right? If you feel like you have to call some other thing, or you have to update that query in some database, you can write your own logic in the Python functions, and you can build that workflow, right? You can put lot of conditions and build, I mean, complicated workflows based on a requirement. So that's what I did.
Okay, so so then one question here actually.
Hmm.
So let's say we have to log into some of the pods maybe running by the Kubernetes and then fetch some of the files and then convert it to the readable format and then represent in some kind of database. So
Hmm.
that kind of workflow, how can we perform in this? Means using the SSH or the Python ways, login through the pod that using
Hmm.
this Kubernetes.
Right, right. So see, I mean, whatever your problem is, first of all, you need to break it down into some simpler tasks, right? The first task is you
Uh-huh.
have to connect to something. Second task is you need to
Correct.
execute it something. Third is to get the
Uh-huh.
structured output. वो आपको बनाना पड़ेगा थोड़ा ना. I mean, on the fly, I cannot
Okay.
tell you, है ना?
अच्छा,
But
नहीं
but
नहीं, so is
हाँ,
it possible from this kind of mechanism means from so that this Gen AI or whatever we are talking about?
yeah, yeah, yeah. I think it should be possible. See, I haven't, I was not able to understand your question fully, but yes, I
So,
mean,
Nitin, it is for only Kubernetes, or you are talking about just some any just containerization only?
See, maybe it will be Kubernetes because nowadays actually everything runs on the cloud. Kubernetes or is used
Mm-hmm.
actually there.
mm-hmm,
So there will be the various pods will be running, right? So
Mm-hmm.
every
mm-hmm,
pod is
Actually,
having the some different
I
kind of
have
I.
just one video with this MCP one, this model context protocol.
Uh-huh,
There
uh-huh.
they have created a one MCP server to dedicate it with Kubernetes servers, and there I have seen this
Okay.
like we were saying there. So they have the MCP server,
Uh-huh.
and then they calling the like a files and all in config file and all as well. There was a video. If I'll get, I'll share with this
Mm-hmm.
good chat. Yeah.
Yeah. Thank you. We'll go through once.
okay.
So, Surinder, I have a question. Here you ask about the Paris. What if that city, you mentioned the city name there in your code, right?
Mm-hmm, mm-hmm,
If I don't have that city name, what would happen? In your description, you mentioned Paris and three different cities there, right?
mm-hmm.
So
If
if I put Delhi there,
mhm, mhm. So I mean, it depends on my function, right? So if Delhi is not there, then maybe it will send the default value. Otherwise, we can also create one tool which is like web. Okay, so it can go to internet or Google. We can use, there is something called the SERP API. Okay, so you can use those SERP APIs also in order to make some Google search. Okay, so that
Okay.
again depends on your requirements, right? If you want, if there is something which is not there in the function, or your function is not capable of, maybe you can go to that SERP API and you can ask your question from the Google. Whatever answer you get, maybe you can put it back into your workflow.
I guess maybe here we
Mhm.
have to deal with the exception actually, is it?
Exception, yeah, yeah.
Correct.
okay, and this you have to give each and every condition here, right? What you want to execute.
Correct, correct.
If
So,
your
so what
function is
happens is,
specific to that,
yeah. So, I mean, what
okay.
happens is after all these nodes, maybe you can create couple of nodes or Python functions which can again check the desired output or not. If the output is not desired, then maybe you need to do something else, right? So that logic also you need to define.
Okay, and your sentence, what is the temperature of this Paris and Fahrenheit are two different variables, right? Those
Hmm.
are coming part of your method.
Correct.
So get the temp. So okay, how those are embedded in between in this particular flow, that particular two dynamic parameters.
Yeah. So what is happening is LLM is first understanding our question. Okay. So our question was, what is the temperature of Paris in the Fahrenheit? And based on our question, it has decided, okay, so it has two different parts. First part is first to find the temperature of Paris, and the second part is to convert it into Fahrenheit. Okay, so when it solves this puzzle of getting the temperature of Paris, it come to know, okay, I have a function to which I need to pass the name of the city, and then it will give me temperature in the Celsius. So once it gets, so now based on my question and based on the definition of the tools which I have appended, it will formulate all those things. Okay, I need to call this function and this is my parameter. So that's the beauty of the LLM, right? So LLM can
So
understand these
LLM
languages.
is deciding, LLM is deciding which are the, in this element, what is the two
Correct, correct.
parameters I need to.
Exactly.
Okay.
So that is the only use of LLM, right? So in this workflow, I'm relying on LLM to decide how to accomplish this task because it was a bit complicated, right? It was not straightforward. Just like human being will decide, okay, अगर मेरे पास ये दो function है तो पहले first I need to find the temperature in Celsius, then maybe I can use the other function to convert it Celsius to Fahrenheit. The same thing LLM did. It used its
Okay.
reasoning power based on the question and whatever content I provided in the method. It decided, okay, I need to call two functions separately, and that's what it did. For the first one, it provided the name of the function and the arguments based on my question. So from the question only, it will parse the city name. And second, for the second function, what is the output of the first function, which was 22? It passed as an argument. This is temperature in the Celsius, converted into Fahrenheit.
Understood.
बस वो यहीं यहीं पे जो the human intelligence which is required, right? The agents, which we say the human agents who are sitting in the support or support calls or executives, right? They all the companies are trying to replace them with these intelligent agents who can understand the question, right, very well, who can analyze the question and then decide also what should be done.
Okay.
All right. So in the maybe in the next session, what we will do is we will further deep dive. I mean, there are a lot of aspects of these LLMs. They are not as easy as I have shown you, right? So there are other things like memory and other things associated with them. So we will learn those things, and then maybe whatever LLM, whatever agentic implementation I have done, I will also show you that also how you can build those kind of applications. Okay, so that will give you some real life that also had the UI user interface also. Okay, so that will give you uh, more idea. ठीक है? Anyone
Yeah.
else has any other questions before we close? I think we can close early today. Luckily.
So,
Nothing as of now.
having any session for deploying our application?
Sorry
For deploying application on
deploying. Yeah, yeah. So yeah, I will
yeah.
plan one session. Batch one was also insisting.
Mm.
So see, deploying these applications are, you know, are equivalent to deploying any other web application, right? We have a couple of options. If we use Google platform or any other platform, we have like EC2 machine. If you want to deploy on EC2 machine, you can use that. If you want to containerize your application, then you can do that also. If you want to use some Azure apps, right? So you can use Azure apps also. So it depends what you want to use. I
So, Surendra, actually, we have also requested to you because,
mm,
as per our discussion, industry will use some cloud provider, not using like a vanilla one, what we are doing there.
mm,
So, it
mm.
would be very helpful if you can show one session
Yeah,
with,
yeah, yeah. I will
as you want,
definitely.
Azure or AWS, and
Yes,
how the
yes.
industry are using these
Mm-hmm.
applications and deploying it there. So, it would be very helpful for
Yeah,
us.
yeah, yeah,
And
yeah.
if you use the container one, then definitely, because Nitin was asking very good questions today.
Mm-hmm.
Because nowadays, everyone is using the containerization. So,
Correct, correct.
if you can show one session like this one, how we can use this tools and these things, it will be very helpful for us.
Sure, sure. I will do that. That's very much in the agenda.
Yeah.
Okay.
Thank you.
All right then, guys.
Thank you
Thank
all.
you.
Can you share? Can
We
you
can
share
stop
this?
recording.
Yeah, I will share this recording in the group. Okay.
Thank you.
And
And
Surendra, I
this
will
code
share that
also.
file for multimodal one. You can check, huh?
Yeah. You share that multimodal file
Sure.
with me, and I will also create that
Sure.
short video, which will help the other guy to solve his problem of that onboarding agent. Okay.
Sure. Sure. Okay. Thank you.
चलो ठीक है. Feel free to WhatsApp me, guys. Okay. If
You
you
can,
face. Yeah.
you
Thank you.
can
Thank you,
stop
everyone.
recording. I will share.
Thank you.
Thanks, guys. Let me stop the recording.